Good afternoon, dear colleagues and guests, or all colleagues here. Well, let me start the session of Dissertation Committee dedicated to defense of the dissertation by Lozkins Aleksejs, seeking a candidate of sciences degree in physical and mathematical sciences in the degree field 051318, mathematical modeling, numerical methods and program congresses, on the topic robust hub location problem under demand and revenue uncertainties. Let me declare this session open in accordance with the Act of St. Petersburg University dated on the 23rd of July 2020. Alexander Vitalovich Prosolov, Doctor of Physical and Mathematical Sciences, Professor of the Department of Economic System Modeling, St. Petersburg University, was appointed Chairman of this Dissertation Committee. As you can see, I am in online mode. I can see you very well. I can hear you very well. Well, I haven't checked how I can hear you. Can you hear us? Yeah, I can hear you. Alexander Yurievich, when he joined, I arrived first. I just left the room for a little while. Well, the sound is very good. So, according to the same act, on the 23rd of July 2020, the following membership of the committee was established. Let me introduce members of the committee: Elena Mikhailovna Perilina, Doctor of Physical and Mathematical Sciences, Professor of the Department of Mathematical Theory of Games and Statistical Solutions, St. Petersburg University; Alexander Yurievich Krylatov, Doctor of Physical and Mathematical Sciences, Professor of Mathematical Modeling of Energy Systems, St. Petersburg University; Abbasov Mejid Elhan Agli, Doctor of Physical and Mathematical Sciences, Associate Professor of the Department of Higher Mathematics, St. Petersburg University; Mazalov Vladimir Viktorovich, Doctor of Physical and Mathematical Sciences, Professor, Director of the Institute of Applied Mathematical Research, Karelin Research Center of the Russian Academy of Sciences. Online with us also is Andrei Valerievich Gurtov, PhD, Linköping University, Sweden. Can you hear and see us? Yes, I can hear and see you. Also online with us as the candidate, present as the candidate, Aleksejs Lozkins, and also with the academic advisor of the dissertation, of the author of the dissertation, Vladimir Mansurovich Bure, a Doctor of Technical Sciences and Engineering Sciences, Professor of the Department of Mathematical Theory of Games, Statistical Solutions in Petersburg University. So we can hear, since our session is partially online, let us check and whether you can see and hear us, and if there's any malfunction in the communications, please inform me, and I will declare a technical break. If there's a problem connecting with me, then I will. Then Elena Mikhailovna Perilina will take up my functions and declare technical breaks. Well, Elena Mikhailovna, do you agree with that? Yes, I do. Well, to improve the quality of communication, dear colleagues that are online with us, please turn off your microphones. But don't forget to turn them off when you're given the floor. I can also inform you that audio and video recording of this session is broadcast online, accompanied with interpretation from Russian into English and vice versa. Also, on the website of St. Petersburg University, the page of this session. An online address is posted where you can send your questions that relate to the dissertation and the presentation of the candidate. These questions will be relayed to me by the technical services, but they have to contain a signature, full name, and affiliation of the author of the question. All questions should be related to the academic discussion of this dissertation, unless the text unless they do not conform to this requirement, they will not be read out in accordance with the procedure of awarding academic degrees of Candidate of Sciences and Doctor of Sciences of St. Petersburg University. Any session of the dissertation committee is deemed legitimate if not less than 2/3 of the established membership of the dissertation committee participates, but not fewer than 4 people. Our committee consists of 6 people. Yes? 6? Am I not a member? Well, including me and 1 member of the dissertation council committee is an online regime, LAN mode. Well, the quorum is there anyway. I delegate to the curator of the defense member of the office of dissertation committee activities support Natalia Vladimirovna Karpova to issue a attendance list in which all present should be entered, and I establish the agenda, and the duration of this council is not more than 2 hours. So the order of work consists of the following items: a short presentation of the chairman about the paperwork that was submitted by the candidate, a short presentation, second, a short presentation of the candidate in more than 15 minutes, questions to the candidate strictly on the presentation, not more than 2 minutes per question. 4 answers of the candidate, not more than 5 minutes per all questions. Then statements from all members of the station, turn by turn, with their reviews, and are covering the presentation of the defendant and of the applicant and the dissertation. And then the chairman will give his review on the research for 10 minutes. Answers of the candidates to all questions and critical remarks of the dissertation committee members. Open floor discussion will ensue, and then the answers will not exceed 20 minutes. Then open floor discussion, 2 minutes per each speaker. All those who wish to speak during this period should register in the log book and introduce yourself when you speak. Number 9. The chairman will read out questions that have been submitted via email to the website of the university. Number 10, the candidate will answer for 2 minutes per question. Then the academic advisor will speak for 3 minutes about the research and about the applicant. Then the members of the dissertation committee will deliberate the resolution of the but whether it will need to do that, and during this period, the broadcast will be switched off. Then an open roll call voting procedure and the counting of votes and the entering of the results into the minutes. And then a decision will be taken as to reward or not to reward the candidate with the academic degree, not to award the academic degree to the candidate, and a concluding statement from the candidate more than 2 minutes. Do you have any objections to the other work? Any objections? Everybody is happy? Well, nobody is offended, and everybody is well. Agreed. If there's no objections, then I will start with the first item on the agenda. First of all, I would like everybody to switch off your mobile phones. Vladimir Matsunovich, what's your situation with the mobile phone? Thank you very much for your understanding. And therefore, I'm continuing. The dissertation of Aleksejs Lozkins, seeking a candidate sciences degree in physical and mathematical sciences, and the degree field of 51318 mathematical modeling, numerical methods, and program complexes on the topic of the hub. A robust hub location problem under demand and revenue uncertainties was accepted for defense on the on this 21st of July 2020. Lozkins Aleksejs wrote his dissertation in St. Petersburg University, as it was supervised by the Doctor of Engineering Sciences, Professor of the Department of Mathematical Theory of Games, Game Theory, Statistical Solutions, St. Petersburg University, Vladimir Matsunovich Bure. The number of publications covering the key issues of the dissertation as numbers 8 works in the publications registered by the Russian Federation Ministry of Education and Science, none in Web of Science Scopus journals, 3 publications. The candidate submitted to the academic secretary of St. Petersburg University a full package of documents to be admitted for defense. According to my information, all documents meet the requirements of the procedure for awarding academic degrees. All of them are in the file available from the Office of Dissertation Committee work of St. Petersburg University. Do you have any general questions to the candidate? Is there any necessity to go over the whole list of documents that were provided by the candidate? No. No questions? No questions. No questions. No questions. No questions. Aleksejs, you're given the floor. Thank you very much. Dear members of the dissertation committee, I present my thesis on the topic, the problem of the robust hub location problem under demand and the revenue uncertainties, that was written in St. Petersburg University. Supervisor Professor Vladimir Bure. The problem of placing hubs is to build a network using special objects called hubs. In contrast to common network nodes, hubs have additional properties such as consolidation and distribution of network flows. The use of hubs allows you to reduce the total cost of network maintenance due to economies of scale. Such problems arise in telecommunications and transport system, where it is necessary to determine the most efficient signal routing scheme, goods and services between the sender and the recipient in order to reduce the overall cost of building and maintaining the network. The process of designing networks refers to strategic planning level. This is associated with the uncertainty of indicators such as demand and revenue. The decision-making process on the configuration of the hub network should be considered possible. Should consider possible deviations in input parameters, be guided not only by the optimal values of the cost of revenue function, but also by the range of their deviations. Objectives of the study. The thesis is devoted to the study of reliability and the problem of placing hubs in a network with objective functions of both cost minimization and profit maximization. The main objectives are to build and investigate the properties of mathematical models for the design of reliable hub networks in the face of uncertainty and demand and revenue, and the development and performance of analysis of algorithms for solving tasks. Research objectives. The following problems were resolved in the thesis: an approach to assessing the reliability of a network of hubs, a criterion for the statistical stability of their number, an algorithm for calculating statistical indicators. A mathematical model was developed for the problem of placing hubs in conditions of uncertainty and demand, where the criterion of reliability is minimization of the variance of transport costs in a compromise for the total cost of the network. Research objectives. A mathematical model was built for the task of placements with the target function of maximizing profit under conditions of uncertainty in demand and revenue. Consider a statistical procedure for assessing the reliability of hub networks, which is designed to assess the sensitivity of the optimal hub network to change in demand. Let us introduce designations for setting the problem of placing hubs in the absence of restrictions on the bandwidth of the hubs and on the number of connections between the hub and the nodal point of the network. The network consists of n nodes, from which a subset of network nodes k are allocated as potential hubs. Parameters such as distances between network nodes, the cost of opening a hub, ongoing flows, the cost of transshipment, consolidation, and distribution of flows have been determined. Two types of variables are used in the task: a binary variable for choosing a node point as a hub, and a real variable for routing a flow from a sender and receive through one-two hubs. Classical setting. The target function of staging consists of the cost of opening hubs and transport costs for servicing network flows. Constraint 2 controls the routing of network flows through the selected hubs. Constraint 3 ensures that the condition is met. All demand must be satisfied. A limit of 4, the constraint 4 is imposed on the number of hubs to be selected. 5 and 6 are the conditions for non-negativity and integer variables. The stated formulation is not new. It is used to describe the statistical procedure. Notations. To formalize the proposed procedure for assessing the reliability of a hub network, we introduce the following notation: abbreviated notation of the optimization problem from the previous slide, where the parameters W and P are the demand matrix and the number of hubs respectively. To simulate the expert estimates of the demand matrices, a multivariate random distribution F is used. The algorithm is iterative, and the number of iterations is set by the input parameters. The main indicator for making decisions about the reliability of the hub network is the hub turnover frequency. Definitions. Definition 1. A network of hubs is said to be resistant to uncertainty in demand given by the distribution of random matrix F. X is the if the hubs coincide for any two demand matrices. Definition 2. A network of hubs is said to be statistically robust to the uncertainty in demand given by a set of scenarios if, for any pair of scenarios, their optimal hubs completely coincide. Definition 3. The level of resilience of a network of hubs is an average indicator of the frequency of turnover of a network of hubs is the set of considered scenarios. A function of comparison of hub networks is introduced in the form of 7, which sums up the number of differences in the selecting hubs for two different demand scenarios. Procedure. The procedure for collecting data on turnover frequencies consists of generating demand scenarios, calculating optimal hub networks, and comparing them for a fixed number of hubs P. Then the resulting dataset is expanded using the bootstrap procedure. As a result of the cooperation of the algorithm, we obtain the rotation frequency of the hub network depending on the number of hubs P. Therefore, the formalized criterion for choosing a stable network of hubs based on the value of at risk is introduced. Consider a random variable the level of turnover of the hub network with the distribution function f z. The VAR value for random level of turnover is a value of that will not exceed with the probability 1 lambda 1 alpha the quartile of the distribution of a random variable of level 1 alpha. Thus, VAR for the number of hubs P is determined by formula 8, and the stability criterion has the form 9. Then I will turn to the problem of reliable hub placement transition in the face of uncertainty in demand. The main difference from the procedure for assessing the stability of hubs, here we consider the process of building a reliable solution where the criterion is the range of deviations in transport costs. We introduce additional notation to the previous introduced ones. A finite set of demand scenarios S is considered. Each scenario is associated with the probability of its realization, PS. A parameter lambda is introduced, which acts as a weight for combining two target indicators, the network cost function and the cost deviation function. Linear setting. The following statement of the problem of placing hubs under conditional uncertainty in demand is proposed. The first term in the objective function is the cost of opening hubs. The second is the expected transport cost, and the third term, together with the constraint 11, is the expected absolute deviations of transport costs. Then the last term is responsible. And then decomposition of Bender's, slide 15. To solve the problem, it is proposed to use the Bender's decomposition algorithm. This method is actively used to solve the problems of placing hubs. This method is actively used to solve the problems of placing hubs. It consists of in dividing the linear programming problem into a master problem. On the slide, these are expressions 17 to 20. And the slave problem or Q on the slide. The algorithm is based on the sections that are added to the master problem, and the sections themselves are built on the basis of solving the dual problem for the slave problem, designated as DSP, where the variables V, W, E are dual variables, accelerated sections. Slide inequality 25 is a cut the section that is added to the master problem at each iteration of the Bender's algorithm. The slide 18, the Bender's decomposition algorithm consists of, in the sequence, solving the MP problem, solving the DSP, constructing a section and adding it to MP. The stopping criteria of the algorithm is the equality of the lower and upper bounds of the objective function. The decomposition algorithm, in comparison with the classical Bender's decomposition, to construct Pareto optimal sections, it is necessary to define an additional procedure for initializing and updating points y. And the numerical experiment. Then the numerical analysis of the present problems and algorithms for finding optimal solution was carried out on the dataset of Civil Aeronautics Board and the Australian Post for various sets of input parameters. The results were compared with the stochastic same where the objective function represents the respected network cost. The graphs show the values of the expected cost depending on the task and the parameter lambda. The results for the stochastic and reliable setting with lambda equaling 0.5 completely coincided. Of interest is the case when lambda is 5 can be seen from the graphs that the costs have increased. This is the cost of the so-called reliability or decrease in the range of cost deviations. Numerical experiment. This graph shows the sign of the coincidence of the optimal hubs in comparison with the solution of the stochastic formulation of the problem. For example, for the case cab 6.u, the selected hubs for the stochastic setting and the proposed reliable setting with the parameter lambda equaling 0.5 coincide, but for lambda equaling 5 they do not. This slide shows the performance graphs of optimization algorithm, and then I will turn to the problem of reliable placement of hubs in the network under conditions of uncertainty in demand and revenue. Let us introduce the following notations. The indirection from the sender to the recipient is now encoded with one index k. And then here the designation lambda has a meaning related to cost. A new variable z is introduced. The volume of demand served is, i.e. the current setting, and it's not necessary to service all demand. The main interest in this setting is the objective function. The first term is the expected revenue for servicing floors. The second, together with the constraint 28, is the expectation absolute revenue deviations. The third term is the cost of opening hubs. The fourth is in transportation cost. The last term is generally with constraint 29 is expected loss of hub. Constraint 33 provides routing through the selected hubs, and 34 determines the amount of demand taken to service. The Bender's decomposition algorithm scheme does not differ from the one introduced earlier. Therefore, we'll consider on the DSP objective function. The expression 37 describes the DSP objective function for constructing classical Bender's sections, 38 Pareto optimal sections, and 39 non-dominated sections. Numerical experiment was used to the numerical experiment used the same data sets as before. Comparisons were made with a stochastic setting. The left chart shows the expected profit. The right one shows the expected losses. It follows from the graphs that when lambda equals 2, the expected profit is about 100 units, less than that of the stochastic setting. But the expected loss of profit is 400 units less, which is the price of network reliability to reduce the expected revenue loss. The time performance of Bender's decomposition algorithms and IB mil log CP plex are shown in the graph. It is impossible to draw an unambiguous conclusion, but the classical Bender's decomposition works better than other methods on average. The graph shows the number of iterations that were required to find the optimal solution, it can be seen that the hybrid method uses fewer iterations than Pareto optimal sections and non-dominated sections separately, but the time spent on iterations negates this advantage. Completion 1. In completion, I present the provisions for tolerance and protection. A statistical procedure for assessing the reliability of the hub network. B. A mathematical model of the reliable placement of hubs in conditions of uncertainty in demand with an objective function of minimizing the accepted costs and expected deviations of transport costs, clause 2 of the passport of specialty. C. A mathematical model of the reliable placement of hubs in conditions of uncertainty in demand and revenue with the objective function of maximizing profit, clause 2 of the passport. Thank you very much for your attention. Thank you, Aleksejs. Do you have any questions on the presentation by the members of the Dissertation Committee? I have a question, yes. Aleksejs, on slide 20, you talk about sections, about optimal and non-dominated. In order to build optimal sections, you have to use classical Bender's decomposition algorithm. You have YH. This is the optimization of master problem. For Pareto optimal algorithm, we don't use YH. We use some dots of. So this is Pareto compared to the previous ones. Non-dominated. We use shifts of the first and the second one. With beta, we have sections. One section and with the second different section. On each iteration, there's this different orders. I have a question. You take some probabilities of these scenarios. What are considerations for the for choosing these probabilities? Well, the distribution of scenarios. The distribution of scenarios derived from the literature. Other researchers did some experiments to generate these scenarios. They used arbitrary upturns and calculated. So what are the considerations? I just used their findings. And some expert, what are the considerations? Well, some expert findings. Well, we just forecast demand in different scenarios, according to expert opinions. Are you satisfied? Yes, I am. Thank you very much. Any other questions from the committee members? Well, no. Then we continue. Then reviews from the Dissertation Committee members and the candidate answering. There are two ways here. After each member of the Dissertation Committee reads their review, the candidate can answer the critical remarks. But since we have So therefore, I suggest that the candidate answers after each review answers the questions, because there are many in each review. No objections? No. Then we give the floor to Irina Mikhailovna. I will not describe what was done in the work, the relevance of the work, the originality of the work. I enjoyed reading the dissertation. I liked the new goals, very interesting tasks in a stochastic probability approach. Well, it's influenced by the advisor, of course. I think that the interesting problems can be resolved in the future and applied in the future. So the applicability is there. So for real, well, I'm not talking about placing hubs in airports, but for logistics companies, transportation companies, possibly. I will go on to the critical remarks. Aleksejs has them. In the introduction, the introduction talks about the reliability. But the definition is introduced later. Well, we should have done it up front. On page 21, you define the cost of transporting units of flows along the route in which two hubs are involved. But they say that there can be flows that use one or two hubs. So can you generalize this task? Can you use in your add to algorithm the routes without a hub, especially when the 2 points that are located close to each other? On page 23, you give a definition of the reliability of a network of hubs as a mean value of the similarity of network hubs, hub networks, but the mean indicator of the similarity of network of hub networks is not defined, or the definition is vague. Well, it's very unclear how you sum up the right part of the equation 2.7. On point 35, you say that y is the optimization as an optimization problem of the second step, but you expect that both y. But the parameter y should be used, but it's not there. In chapter 3 is important mathematical formulation of the problem that the parameter lambda, but any practical, but as far as I'm concerned, in some applied problems, you should use a specific interval of values. Maybe it should be determined empirically. Do you have any practical recommendations in the literature on this account? But this all doesn't diminish the positive attitude, my positive attitude to the work. As far as the first one, that there's no schism. Aleksejs, please talk loudly. The data used in the work, these concepts differ depending on the chapter, but the main idea is to neutralize the influence of the uncertainty of the parameters of this decision. This is the general idea of the reliability. streams passing through the one hub are taken into account. In this case, it is the indices responsible for the hubs in the root are equal. The dimension of the problem depends on the number of stream variables or flow variables. Their number is defined as the number of nodes and in the power of the number of indices. In the literature, there are works in which an incomplete graph and connections between hubs is considered, which significantly reduces the task. Therefore, this approach can be used to design a network of hubs in an area. The problem of considering direct connections without hubs is not new, and the number of works, the works are devoted to it. As far as the and so in the classical setting, direct connections to the network are not provided. In the definition, which is more appropriate to use rotation frequency, that's number 3. As far as the Russia, in the hubs, different hubs. Well, you can use. There are some. So the terms of Russia, yes, I agree with you that the complexity of the problem can be diminished. As far as the direct connections, there are no work. The problem considered direct connections without hubs is not new. But there are no real work direct covering this. As far as the definition, it is more appropriate to use rotation frequency. Yes. As far as the constraint 3.2. Well, no. On the right-hand side of 2.7, the Boolean values of the equality variables are summed up. That is 0 if the values of the variables are equal to 1, and 1 if they're not if they're equal. Constraint 3.2 is included in the problem Q. Why this constraint uses Y. In the task of placing hubs, there were no similar formulations yet, but in the task of optimizing the workforce in the hotel business, for example, a similar concept was applied. As far as I know, it also did not specify the interval. So what can you use? Lambda equaling 1000. Well, less than you used less than 5 and 5. Are there any reasonable boundaries here? If you take 1000, the coefficient will be will tip over the optimization. Well, we have. Well, in this case, the whole weight is on this part of the function. So the experiment, well, the goal of the experiment determines the experiment in this case. As far as the designing hub networks refers to strategic planning, i.e., for several years, and thus the demand is considered for this period of time, and the result, the cost of servicing it become commensurate with the cost of opening the hubs. Note that for this reason, it is important to consider uncertainty in demand and revenue. So the hubs are set up for a lengthy period of time. So, well, as I said, the costs are commensurate. As far as the the typos and mistakes in the text, I totally accept them. Thank you very much. The next review presented by Krylatov. Thank you very much. I also positively appreciate value this work, but I will then now critical remark turn to my remarks relate more to numerical experiments because they're a very important part of the work. I think that in some chapters, very few examples are sampling is too small. Well, for example, in chapter 2, you consider only a network consisting of 178 nodes, but the potential points of the network where you can place hubs consists of a set of 10 nodes, and I think you should expand your experiment and get additional practical results. In some, and then the second critical remark is that in the literature, when they provide in your publications that deal with numerical experiment, you use the software package product IBM iLog, CPLEX, but in the work, in the thesis, you also use Gurobi optimizer. Why? And also acronyms. You introduce acronyms to designate problems, and some of these acronyms are unreadable or and my last question: are there any results that we can use in distance learning or machine technology? So this is not a critical remark. It's just a question whether you have any recommendations. I'll start with the neuron and IE, neural networks and IE. And of course, we would have to we try to solve optimization problems using AI, sorry, but we didn't achieve much. Well, in America, they built a neuron network to optimize city transit, and they used. That was a real-time problem task, but here we're concerned with the precision, and I understand that. To assess the parameters, maybe you could create create a framework to find parameters and assess them. I introduced the concept of arbitrary matrix. well, usually we use expert opinions, but of course we could use, well, in order to get those expert opinions, we could use some algorithms. Well, I didn't deal with that in my thesis, but certainly experts use those. As far as the data used in the calculations, well, in the second chapter, and I used the data that I received from the logistics company business lines. The constraints provided were used to keep the experiment realistic. As far as the solvers, at the moment, Gurobi optimum is the fastest in the field of solving linear programming problems, and IBM iLog CPlex is one of the oldest products for solving linear programming problems, and as a result, the most used in scientific experiments. Comparisons were made with each solver mentioned. So then. So in my publications, I used the IBMs. Well, there was one more question. Yeah. Once the next review is by Abbasov. I will not talk about the relevance and the regionality. I will just dwell on some. Placing hubs problems have been studied by many researchers, but the author contributed to this problem that he looked at it from a point of view of probability. Mathematical problem was set to assess uncertainty. In real life, you cannot forecast, prognose. You forecast the demand in different points and the time of moving between points. And we can talk about some arbitrary values that can be governed by some law, and this was done in the thesis well, from mathematical perspective, and well, it was one thing to set a problem, but another thing is to provide algorithms to solve this problem. And on this way, that what I liked in this problem, in this way, there should be a baggage of knowledge from different fields of mathematics, bootstrap method from statistics, financial mathematics. Portfolio theory, as far as I understand, value at risk is derived from multi-criteria optimization, mathematical modeling, and there was a lot of work done, and the erudition from knowledge from different fields, and then the author had to combine all this to solve the problem, and so it's very valuable. As I also want to mention that this work is important and valuable in that the author provides methods that are programmed, because available are programming software packages where you can turn to and get a solution. This is very important. Applicability is there. The next thing is, and of course there are some some additional non-standard problems that you solve. All these moments were resolved very wittingly and elegantly. And as a conclusion, I would like to say that the work as very valuable, complete work, and I enjoyed reading this work. But of course, there are some critical remarks to receive your answers. And the first one is you use Bender's decomposition method with Magnati 90 and Wong sections in which points from master problem are used, but you never studied the issue of choosing such points and their influence on the speed of the algorithm. And you heard that from from my colleague. In chapter 2, as number 2, the demand is modeled with the use of some continuous multi-dimensional arbitrary distribution, but you don't discuss the issue about the base, which exactly law of distribution should be used by the researcher who wants to use the results of the work. In the text of Dissertation, you use the word reliable in different senses. Well, maybe you should vary because it makes the reading confusing. And in chapter 3 and 4, you have mathematical formulations of statements. But indices of analogous variables differ. Well, in chapter 2, you have different designations. R, for example, in section 2.2, this is the number of iterations, and 2.3 is the set of numbers. And well, as far as the Magnati and Wong, there are a number of works in the literature that investigate this issue. During the numerical experiment, its results were used to initialize and update the Magnati and Wong's points. Their study is undoubtedly of scientific interest, but this task was not included in the dissertation search, but can be done later. This is what about mathematical. The process of modeling demand by multivariate random distribution platforms, the function of imitating a forecasting system of expert assessment of demand, therefore it is not the result of research. As far as the this is not the result of the in the scope of the research. So distribution is a set of scenarios. Well, in chapter 2, and the scenarios are formed by some neuron networks. There are different parameters used, the expansion of networks, and the experiments used this distribution to model this case. As far as the reliable, the term reliable, yes, I agree with you that in each chapter I had to clearly specify what I mean by reliability, the term reliable. Well, that's because the concept are a little different from chapter to chapter. The next The next review is from Bazalov, Professor Bazalov. Dear colleagues, I liked Bazalov. I liked the work. Very interesting results have been obtained. The optimization problem are nonlinear programming problem as the work, the results are published in good journals, and this attests to the fact that the work is worthy of the third degree, of awarding the third degree to the author. But I would like to point out some critical remarks. In the optimization problems, you don't discuss the existence of an acceptable solution. In the functional of 3.6 on page 31, you weight two criteria, but there are no recommendations to how to choose the parameter of lambda. On page 42, you introduce capital K incorrectly because it coincides with the previous designation of a set of hubs. And then page 50, the functionality, the functional is the profit of the carrier is the functional. Of course, the carrier is interested in servicing an optimal number of requests or orders, but in practice it doesn't happen this way. There's a market, and companies fight for orders. In section 4.8, you have numerical experiments, and you say that the algorithms exceed the known software products Cplex and Groby, but in the text you only provide results of the work of the programs programs provided by the author or designed by the author. Well, you should also provide calculations obtained with the known programs, and then compare them with your results. This number 6, the speed of solving optimization tasks for hybrid algorithm, which uses a section of optimality section and maximal non-dominated sections. You say that it's in some cases it is less in productivity to the algorithms of Bender's decomposition with the same section, but in isolation. But when you when you describe the algorithm of constructing these sections, you can presume that the calculation of these sections can be done in parallel process. In robust 4.13 setting, uncertainty in the choice of lambda k. The work is written in Russian, but in some cases it looks like it's a translation from English. But nevertheless, I endorse this work. As far as my answers, the question of the existence of a solution to the problem that it is not considered since the classical formulation of the problem is used as a basis. Well, it's not considered because the classical formulation of the problem is used as a basis for which this question is investigated. The modifications made do not contain additional restrictions that could affect the existence of the solution. Well, the probability is stochastic. Well, there are some. The comparison. In chapter 3 and 4, the comparison was made with the stochastic classical models. The lambda parameter regulates the degree of influence of the spread of transport costs on the decision. Its range of acceptable values is determined expertly depending on the task and goals. If the parameter is set large enough, then the solution will be more expensive compared to the optimal, but the risk of increased costs will be less. Well, so the overbalance again will be to the minimization of risks. As far as the designation, K, yes, has the same meaning. There's a procedure that comes from the literature as the lambda with the index K is the revenue of servicing a stream unit, which differs from R in that it includes the level of service, competitiveness, network coverage, and other parameters. Well, as far as the your next question, this is a flaw in the formulation of the problem of placing hubs with the objective function of maximizing profit. However, in the proposed setting, a loss function is considered, which in some way takes into account the level of service, allows us to consider scenarios of demand depending on the price, and of course take into account competition. So if you I consider here the most profitable flows and then for the company services these flows. The company compete for to expand their services. They cannot afford to service flows that are not profitable. As far as the optimization time in Kurobi and CPlex, they are shown in tables 3.2, 4.2, 4.3, 4.6, and 4.7, where I the last column times. As far as the hybrid algorithm, I agree that for the hybrid algorithm it is possible to calculate cross sections in different flows, but in order to compare the time efficiency of using two reinforced cross sections in comparison with reinforced cross sections, one flow was used separately. As far as the lambda, with the problem of in chapter 4, in chapter 3 we have this is weight coefficient. Here it's an in the parameter of revenue, and the final remark. Some parts of the themes are translations of articles published by the author. Yes, that's correct. Well, most of my papers were written in English. I tried to because I wanted to publish in English, and here are the translations. That's true. The next review is by Gurtov. I like their work. A good level. I will not read my review. It's placed on the website. I will just say that it's relevant. It uses relevant issues, tackles relevant issues. In Skype, super nodes are used. They're responsible for the functioning of the network. And I will just get to the critical remarks. Some of the remarks were voiced by my colleagues. The absence of between hubs to fly from St. Petersburg to St. Peters to Moscow via New York. If New York is the hub of the company, is still not viable. So the conclusions, unfortunately, don't meet the practice. Transportation. Right now, hubs are being abandoned, and the direct flights are introduced. Airliner Airbus 300 was actually taken off the production because it carries people on over very long distances. Well, I also mentioned that A380, sorry, and also you use in the dissertation use the model of air travel in the USA, but this trend was not discussed, and the formulation of the problem UMA PHLP PHLP uses some undemocratic formulations, and that's that the connections between nodes, non-hub nodes, are forbidden. Therefore, you restrict the movement of the choice of optimal routes for consumers. Yeah, thank you very much. As far as the numerical experiments data from the Civil Aeronautics Board, this is a classical set of data, well, which is included in every study. I used it as well. Yeah, well, for this work, I agree that the data are a bit outdated, but this because they belong to the 1980s, when almost every work still uses it. My dissertation is no exception. Well, as far as the classical formulation of the problem placing hubs, there are no direct connections, but there are works in the literature that consider deviations in this direction. For the purity of the experiment, the work is used is the simplest formulation to the problem. traffic accounting. This has to, as far as the the direct and as far as the traffic direct as far as the traffic accounting and availability of hubs are sources of uncertainty that are also explored in the literature. But looking at uncertainty in profits is a fairly new direction. As far as I know, at the time the dissertation was sent for consideration, the uncertainty in revenue was considered only in one scientific work, the dissertation. Well, we used formulations that are the simplest for modification. As far as the as far as the computational experiments, they were carried out on an ordinary machine without using special service. For this reason, tasks with a large number of nodes in the network were not considered. So, in my experiments, I used memory. But if you used a local machine, then the experiments would take too long. As far as the algorithm presented in the work, they are sequential, but I see an opportunity to use and combine the proposed algorithms in parallel process with synchronization at intermediate stages of section construction. This could, of course, be a continuation for my research, but in this work I didn't set this goal. Working with series clusters. Thank you very much for your answers. And then I will talk what I think about. I'll have a very short presentation. I liked everything. I liked Aleksej's answers. That Aleksejs reacts to questions, and I think that this work is strong, and the author deserves the degree. I just have one critical remark. Well, about the matrix of W. Well, I just said that I'm certain. I'm not sure about the criteria for well, in the dissertation. You operate uncertainty in demand, the term uncertainty, and you review different methods, but which one is the best and on what criteria? Lozkins doesn't exist. So do we have any participants of this session who is not member of the dissertation committee, who would like to speak? Natalia Vladimirovna, any external requests or reviews, questions by email? No, nothing has arrived. everybody is in isolation, self-isolation. So then the floor is given to the academic advisor. I will just talk about the candidate. Aleksejs graduated from school in Latvia and won a grant to study at St. Petersburg University. And then after receiving a bachelor's degree, again he won a grant to study at master's level programs. And that's when we met, and Aleksejs was interested in the problems that I was interested in, and so he asked me to supervise his dissertation. In master's degree programs, he received a scholarship from the government of St. Petersburg. He participated in an international conference in Latvia. He published 2 papers in Scopus. In the second year of the master's program, he started working for a private company, which delegated him to conference in the United States, and then later delegated to Neurobi to study Neurobi optimizer in different countries, and he graduated with an excellent grade from with a master's degree, and then he joined a doctoral program. Again, he won a grant to study for an internship as a study abroad program in Brazil. In Brazil, he spent a month there, or even 2. After that, he suddenly switched to studying Portuguese, mathematical description of the Brazilian dialect of Portuguese, and then again he published a Scopus paper on this topic, and of course he graduated with a top grade from the doctoral program. He has worked in different areas, developed recommendations in different fields. We have a paper on Portuguese, mathematical modeling of this area. He has always worked for this private company, studying the business, and independently he started being interested in economic mathematical modeling, statistic simulation modeling, and there are different stochastic upturns that are part of his work, and he then turned to optimization problems, and he studied them absolutely independently. I had no part in it, and then took up hub placement problems, and then saw some clustering solutions, and this is the dissertation has references to 4 Web of Science and Scopus publications, and the dissertation doesn't mention 2 more works that are indexed in these databases. One is about the language, and the one is about about the machine processing of natural language, and one is the incorporation. That one is the incorporation with Brazilian specials, and in methodology, it's very similar to what Dissertation uses. I would like to point out Aleksej's ability to organize his work, time management, and do what has been set. Many can do that. Not many researchers can do that, and he's capable of doing it. Therefore, he could combine working for a private company with, heavy responsibilities and this research. And the spectrum of this research is very wide. There was a period when Aleksejs wanted to concern with biological problems, investigating biological problems, but now he focused on the on business and economics problems, and very successfully, I think. Thank you very much. We are continuing. Dear colleagues, we went through the whole cycle with of getting acquainted of the Dissertation Committee, getting acquainted with the candidate. Do we need a closed period of discussion, deliberation of the verdict, or is it all clear? Everything is clear. Everything is clear. Therefore, we continue and we come to the point of voting. Then no break is needed, so we can hear and see each other. And therefore, I put to the vote a resolution of awarding Aleksejs Lozkins an academic degree of candidate of physical and mathematical sciences in the degree field of mathematical modeling, numerical methods, and program complexes. On the topic, robust hub location problem under demand and revenue uncertainties. And this will be a open roll call vote. And I just remind you that more than half of the Dissertation committee members should vote in order to take the positive decision, but not fewer than 3. Elena Mikhailovna Perilina, I agree with the wording of the Alexander Yuryevich Krylatov. I vote in favor. Abbasov Majid Elhamagli, I vote for the decision. Vladimir Valeryevich, I support the resolution. Andrei Valeryevich Gutov, I vote for the resolution to award the degree. And I, as chairman, Alexander Vitalyevich Prasolov, I also vote for the resolution to award the sword degree. Therefore, we have 6 members of the Dissertation Committee voting for the decision, and no one voted against, and no one abstained. Therefore, the decision to award Aleksejs Lozkins an academic degree of candidate physical mathematical sciences and the degree field 05-13-19 mathematical modeling, numerical methods, and program complexes is taken. And dear colleagues, because our session includes members of the Dissertation Committee in an online format. Do we have any questions in terms of the procedure? Please, no questions, no objections, no questions, no questions. No, no. Alexis, do you have any questions? No questions. Therefore, your concluding remarks. Thank you very much. Thank you very much. I would like to thank my academic advisor for the mentoring, for the guidance, the very heated discussions of the material. And I would like to thank the university, the Ministry of Education of Russia, for allowing me to study here for so many years. I would like to thank my colleague that I cooperated with my superior, Krasinenko Mikhail Vasilyevich, because we discussed this topic with him so many times. Very useful for me, and very good criticism on his part. And then thank you very much to my wife, who helped me with the Russian language, and for the support. Thank you very much. Thank you. The session is declared closed. I thank all the participants for participating. Please switch off the broadcast. Thank you very much.